Suppose I have a capacitor of capacitance C, and it is attached to a battery of V. So what is going to happen is that the charge that is accumulated will accumulate itself according to this equation. Now I am going to do what? I am going to disconnect the battery. And disconnect battery.
After charges got accumulated.
After?
Are you disconnecting it?
Fully charged. See, right now we are doing only fully charged. Till the end of our capacitors, we will be doing fully charged situation only. Charging situation we will do after we do current electricity. We will involve capacitors and resistors, and then charging story comes into. So right now we are doing fully charged. Okay.
Yes,
sir. Not halfway through or zero charge. Okay. Now, so story is this: we have a capacitor of capacitance C attached with a battery V. The charge that is accumulated on the capacitor is going to be CV. Now I am going to disconnect the battery. Okay. Now when I disconnect the battery, what is happening? The capacitance will be remaining as C and the charge will be remaining as Q. Okay.
Yes, sir.
Suppose if I attach this. So let's take this as V1. Disconnect the battery and attach to a new battery.
So till then the potential difference will be V1.
Correct. Right now the potential difference will be V1 only, even after disconnecting it with the original battery. Positive charges are on the left side, negative charges are on the right side of the plates. Now I will attach it to a new battery. The capacitance is still C, and my new battery will have a potential of V2. So the charge that is accumulated now, Q dash. So the excess charge that has come on the plate, if V2 is greater than V1, or we will write this also as Q1 and Q2. If V2 is greater than V1, then the excess charge. So he will ask, how much charge did the conductor provide to the capacitor? How much more charge did the conductor provide to the capacitor? You know that the charges are flowing through the conductor. Battery is not giving charges. Battery is giving potential difference. Battery is not giving charges. Battery is giving potential difference. The conductor has charges, which is basically accumulating the charges on the walls of the capacitor. So how much of excess charge has flown through the conductor? Excess charge flown through conductor is nothing but Q2 minus Q1 is nothing but C times V2 minus V1. Is this clear?
Yes, sir.
V2 is greater than V1. This Q2 minus Q1 fellow will be greater than 0. You can say that the excess charge has flown through the conductor to the capacitor.
Yes, sir.
Now, if V2 is less than V1, the charges have flown from the capacitor to the conductor, and your Q2 minus Q1 is going to be negative.
Sir, so it will go back.
Correct.
Where
The
will
charges from the plates of the capacitor will go back to the conductor.
which kind? I mean the wire.
This wire itself is a conductor. Yes.
Sir, so charges will be
In the
sitting there.
conductor. Yes. Imagine this. I have a capacitance. I mean, is this clear?
That is clear, sir.
Here, what we are saying is if Q2 is greater than Q1, further charges have flown from the conductor to the capacitor. In the reverse case, where V2 is less than V1, charges from the capacitor plate is going.
Potential to low potential.
Correct. Okay, now talking about, suppose the capacitance is 1
Yes, sir.
and the voltage is 1, the charge is 1. Correct?
Yes, sir.
For the same capacitance, if the capacitance is 10 power 3, the charge is 10 power 3, according to the equation.
Yes, sir.
I am going further crazy. I said no, voltage is 10 to the power 50. Very huge number.
Charge is 10 power 50.
Charge is also 10 power 50. 10 power 50 charges, from where will it come?
From the battery.
From the conductor. Battery does not provide charges, it provides potential difference.
Sir, then the charges in the conductor will be automatically
Finish off. So you can find the number of charges present per mole. Therefore, in the entire conductor, you can find out how many charges are available in the valency shell.
Like we should find number of positive charges and negative charges separately, and then
How do you find number of positive charges? Conductor has.
they know the atomic number, right? They'll give the weight of it.
When you say number of positive charges, that means it is protons. There is no such thing as positive charges flowing.
Then why did you tell positive close to that?
Positive conductor, we discussed about conductor, it gives free electrons. If from an isolated conductor I take minus 10 coulombs, then plus 10 coulomb will be created. There is no such charge going plus 10 coulomb. Minus 10 coulomb flowing is electrons.
Yes, sir.
But plus 10 coulomb is not protons. Going and playing with protons is nuclear energy. Protons are inside nucleus. Whoever goes inside nucleus and sings a song will go to North Korea, Russia. That is not a small energy, right?
Yes, sir.
So I have a car which runs on battery, and I switch it on and that toy car is moving and nuclear things are happening. No. You have a battery in the car. You have, of course, a conductor. Electricity flows only through conductor. If really protons are moving, that means we have Russia here only, right, in the toy car.
Sir, then until now in the previous questions, why did you write positive towards that side and negative towards other side?
I am writing here also that this is positive terminal and this is negative terminal, and the positive charges are accumulated on the left side of the capacitor. Tell me, what is this meaning? This meaning doesn't mean that I am sending protons through battery or conductor. We are not playing with protons in any of this story.
Sir, so basically electrons are moving towards the left plate and electrons are moving towards the right place, and over there the positive and negative charges are getting accumulated.
Correct.
I mean,
yes. Hi guys, I hope you enjoyed this session. If you think this video was useful, Don't forget to like, share, and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.